Hey chemistry students, welcome to your tutorial on noble gas electron configuration, aka the shortcut you've all been dying to know. So we're going to go through two examples today. The first one is going to ask us to write this shorthand version of electron configuration, and the second example is going to ask us to use the shorthand electron configuration or noble gas electron configuration to identify the identity of our neutral atom. So let's jump right in. So we're going to do the noble gas configuration for both aluminum and calcium. So as before, we need to know the number of electrons before we can even start. So aluminum, I'm going to look at its atomic number, has an atomic number of 13. Calcium has an atomic number of 20. So I'm going to write both of these down to the side just as a reminder of how far I need to go. You don't have to do that. All right, so the noble gas configuration trick, find where your atom is. So here's aluminum. Then you're going to find the noble gas in the period above. So remember, periods go across. So I'm going to put neon for aluminum, and I'm going to put that in brackets. I'm also going to make note of the number of electrons for neon, and neon has 10. So by putting this bracket, what I am saying is that aluminum has the same electron configuration all the way up through neon and then some. So what else I'm going to do, I need to remember what I learned about the blocks of the periodic table. This over here is the P block. So neon's electron configuration ends in 2p6. Argon ends in 3p6. If you don't believe me, try it out for yourself. So on and so forth all the way down to 7p6. So I'm going to find where neon left off in my alpha chart. So neon ends, it goes 1s2, 2s2, 2p6. So this is where neon's electron configuration ends. So I'm going to find this point and then keep going until my top number adds up to my number of electrons for aluminum, so 13. So I'm going to write 3s2. Once I end here, I've got to come back around, and then 3p1. So your numbers should all equal up to 13. So neon stands for 10 electrons, plus another 2, plus 1, 13. All right, so let's try this for calcium. So here's calcium. It's in group 2, period 4. So I'm going to find the noble gas in the period above. That's argon. So I'm going to write argon in brackets. Argon has 18 electrons. I'm going to make note of that. And I'm going to find where argon ends. So argon ends at 3p6. I'm going to find that on my alpha chart, which is right here. And I'm going to keep going. I'm going to carry on from this point until my top numbers, in addition to this 18, add up to 20. So 3p6 is where we left off, so 4s2. 18 plus 2 gives me 20. So I'm good on that one. All right, on the second problem, given the noble gas electron configuration, identify the following neutral atoms. So on this type of problem, what you'll need to do when you're given the noble gas configuration, your first step, locate these noble gases in group 18 and determine their number of electrons. So krypton has 36, you may not be able to see that, electrons. I'll look at its atomic number, so I'm going to write 36 above just to help me. Now what I'm going to do is add my number of electrons for my noble gas to the number of electrons in my remaining electron configuration. So 36 plus 2 is 38, plus another 2 gives me 40 electrons. So since this atom is neutral, that means its number of protons and electrons will be the same. Meaning I'm looking for an atomic number of 40. So I'm going to peruse my periodic table. I find it. So Zr for zirconium. I'm going to do the same thing with the second question. So I'm going to find the number of electrons for argon. Argon has 18 electrons. I'm going to add the remaining electrons to this number. So 18 plus 2 plus another 7, and I get 27. Now I'm going to look on the periodic table for the element with the atomic number of 27, and that is cobalt. CO for cobalt. Alright, I hope you enjoyed this shortcut with noble gas electron configuration. Practice on your own. Ask me questions as always, and thank you for stopping by.